at vectors acting along one plane, vectors along two planes yesterday. Okay, then realize that when vectors, two or more vectors are acting along one plane, the resultant is a summation of all the vectors or summation of all the vectors when they are along one direction or subtracting a lesser sum from a larger sum when they are moving opposite way. Okay, and then we also saw that when they are perpendicularly related, you realign their directions and then use Pythagoras theorem to determine the resultant vector and to determine the direction as well. Then we got to when they are at an acute angle, either an acute or obtuse angle, any angle theta. Okay, here we realize that we will use the cosine rule for determining the direction, the magnitude of the resultant force, and we will use sine rule to determine the magnitude of the to determine the direction. Sorry. Okay. Now, so yesterday I gave you an example where the angle between the forces 60. If the angle is obtuse and an obtuse angle lies between is greater than 90 for obtuse angle, it is any angle greater than 90 and less than, yes, an obtuse angle greater than 90, less than what?
180. 180.
Or 180. Good. So yesterday we looked at obtuse. Let's look at when you have maybe an angle of an obtuse angle of 120 or so here the angle between the two forces 120. It falls within this. This magnitude is 15 Newton. This magnitude of the force, this is F2. This is 10 Newton. F1 is 15 Newton. Okay. So here, the value approach is still the same. Since the directions do not make any sense. Okay. This is going here, this is going here. So you have to realign their direction so that it follows a sense of orderliness by resolving this into a parallelogram. But note this, for vectors, once this vector, okay, starting from here, is the same as this, I can draw the magnitude of this vector, 10 Newton, from here. So from this point to this point, it's still 10 Newton. Then bring this direction here. And once this vector, this is the original vector, this new vector has the same magnitude and direction as this, I can clear this and still have this. Then this one too, I can draw a vector from here, same magnitude as this one. Then maintain the direction. From here to this point, have the same magnitude as here to this point, that's 15 Newton. When the direction magnitude is the same, this is also the same as this. Okay. So for vectors, once you maintain the magnitude and direction, you can express it in different ways. Take note. So,
Mr. Adria,
hello.
Mr. Adria, does it mean that even if the object moves in different angles, but yeah, if they move in different angles, it doesn't affect the forces like the 50 Newton and 10 Newton.
The vector, the vector can be the same so long as it has the same magnitude and direction. That's okay. So
Yes, please.
look at the original one. The direction was here. Once this is the same as this, look at something. This angle 120 is also the same as 120. And so I can clear the original one. Once I have the same magnitude, 15 Newton, 10 Newton is the same. It doesn't change it. Is that okay?
Yes, please.
All right. So let's go back to the original question I gave you. We have this vector, the angle between this is 100 and this is 15 Newton. This is 10 Newton. The angle is 120. Bushra, mute yourself for me. Bushra. Okay. So let's resolve this into a parallelogram. And Bushra, mute yourself for me. So we are creating an equal component, okay, on this on this one. So long as the magnitude and direction the same, okay, then I'm creating this one too. So this is equally 10 Newton. I'm creating this one too on the 10 Newton. So long as direction, magnitude, direction the same, I'm good to go. Now, once we have realigned the direction, if you look at it from up, this, the resultant is here. And each side, whether this side or this side, obeys the triangular law of vectors. Okay. But you see, the triangle law of vectors applies to scale drawing. Okay. So because this is not done, if I want the resultant, I will use the cosine rule. Squared is equal to f1 squared plus f2 squared minus 2f1 f2 cos of this angle opposite to the resultant can be this or can be that, depending on where you want to, which side you want to use for your calculation. Now, what is this angle? Yes. Plus, what is this angle?
180 minus the angle.
So, once this and this are parallel, the angle here is equal to the angle here. So this is also 120. Therefore, this is 60. Are we okay?
Yes.
No, please.
You see, this vector is parallel to this. We formed a parallelogram. And in the parallelogram, opposite sides are equal and parallel. And parallel lines have the same slope or gradient. So the angle from this vector to this is equal to the angle from this other parallel line to the horizontal. So if this whole angle is 120, this will also be 120. And so this will be 60. All right.
Yes, please.
But don't forget this angle is actually like cos of, okay, this is like 180 minus 120. So this is 60. So in effect, this is cos 180 minus 120. Okay, which is 60. Therefore, let's put in our values. 15 squared plus 10 squared minus 2 times 15 by 10 and the cosine of 60 degrees. Okay, so this is 225. Hey, Bushra, your microphone is on again. This is 100 minus 2 times 15 times 10. Cos 60 is half. So this and this will cancel. So I have 325 minus, this is 150. Okay. 150. And so the answer is 100 and what's the answer? Is it
175.
175 for r squared. Now r is equal to the square root of 175. And that is square root of 175.
2.23.
13.228.
So that's the resultant. Okay. Then the direction of the resultant. The direction of the resultant, this acute, this small angle. Okay, and yesterday we were determining direction of the resultant using sine rule. Okay, sine rule. Let's extract that diagram. So this is alpha. This is the resultant. This is 15 in this direction. This is this. And this angle is 60. So if we want this, sine of alpha over 15 is equal to Anna or Amma, your microphone is on. It's equal to sine of 60 divided by R. R is this. So you can clear this and put 13.23. Therefore, sine alpha is equal to, when you multiply 2 by 15, you eliminate this and then have only sine alpha at one position. So 15 by sine t divided by 13.23. And 60 is root 3 on 2, which is 0.866. So 15 times 0.866 divided by 13.23. Please put them together and give me the final answer. What is 15 times 0.866 divided by 13.2?
0.98.
0.98. Okay. And when you take the sine inverse of this will give you something close to 80. Check. Maybe 89, 88, 89. Sine inverse of this.
79.07.
Okay. So 79.
07.
No, 78.5.
79.078.
07. Okay, so approximately 79. We usually take the angles to the closest degree. So that's the direction of the result. Please take note that this cos 180 minus 120 is equal to negative cos of 120. So it means that we can just clear cos 180 minus 120, which is cos 60, and then put in negative cos 120. But because negative and negative, this will change to plus, so that we could use the angle given to us in a formula direct. Okay, please, are we okay? And it will give us the same result. All right. Okay. So that's the solution. Do I clean the board or you are still writing? Are you writing or I can clean so we could continue?
Yes, you can clean.
You can clean.
Okay. Now, the cosine rule is actually a formula which applies to two vectors acting in all manner of directions. Whether the two vectors or vector quantities are moving along one plane in one direction, opposite direction, perpendicular, or whatever. So the cosine rule, yes, applies to two vector quantities, but it applies to two vector quantities in all manner of directions. You see, when two forces or vector quantities are moving in the same direction, we said the angle between them is equal to what?
0.
0 degrees. And how do we determine the resultant? What's the resultant?
Addition of the vectors.
So R1, F1 plus F2. We can use the cosine rule to get the same thing. Look at it. R squared is equal to F1 squared plus F2 squared. Okay, if you are subtracting theta from 180, it's minus. If you are using theta plus 2F1 F2 cos theta. Now, because these two, if I want this, all that I do is that what is the direction of this? The direction of the angle between the two forces, 0. So substitute theta for 0. Cos of 0. And what is cos 0? 1. Okay.
Yes, please.
So you have f1 squared plus f2 squared plus 2f1 f2. Okay. Now look at something. If you have f1 plus f2 all squared, how will you expand this? Expand this for me. f1 plus f2 squared.
It will be F1 squared
f1 squared
plus 2F1 F2
plus 2f1 f2
plus F2 squared.
plus f2 squared. So you realize that this part, when we substituted 0 into this part is the same as this, isn't it?
Yes, please.
Yes, please.
So you have r squared is equal to, since this is the same as this, f1 plus f2 all squared. I want r, not r squared. What do I do? How do I get r?
Take the square root.
So when you take the square root, you have f1 plus f2 all squared. Square root of that. And this is equal to what?
F1 plus F2.
Is it different from what we had earlier?
No, please.
So we are using the cosine rule. All that we are doing is that, we know when they are parallel along the same direction, the angle between them is 0. Let's substitute 0 into this, and it will give us the same thing. Let's look at another instance. When the two vectors are opposites, they are acting concurrently on a body at the same time on a body. This is F1. This is F2. What's the angle between them?
180.
180 degrees. Okay. So R squared is equal to F1 squared plus F2 squared. Here I'm using minus 2F1, F2. Don't forget, when you use minus, it should be cos 180 minus theta. When you are using plus, it should be cos theta. I hope you have the trick now.
Yes.
Theta here is equal to 180. Put it in. You have F1 squared, F2 squared minus 2F1, F2, cos 180 minus 180. So this is 0. Cos 0 is 1. So you have F1 squared. This is 1. So minus 2F1, F2 plus F2 squared. And this is equal to, this part, the underlying part is equal to what? Yes. The underlying.
F1 plus F2 all squared.
No, look at it again. The underlying part is equal to F1,
F1 minus F2
exactly, F1 minus F2 all squared. Therefore, R will be equal to F1 minus F2. This is on condition that we are saying F1 is greater than F2. If it's the other way around, you have F2 minus F1. So we are using the cosine rule to get the same thing as this. All right.
Yes.
Now
Yes.
let's look at two forces or vector quantities. They are perpendicular. When perpendicular, we realize that the resultant force will be equal to the resultant force R will be equal to what? Yes, help me. If they are perpendicular, R will be equal to
Root of F1 plus F2.
so root of F1 squared plus F2 squared. All that I do is that into this, theta is equal to 90 degrees. So substitute 90 for this. R squared will be equal to F1 F2 squared plus 2F1 F2 cos of 90. Cos 90 is equal to what?
0.
So all this side goes to 0. So R squared is equal to F1 squared plus F2 squared, and R is equal to square root of F1 squared plus F2 squared. So the cosine rule actually applies to two vectors acting in all manner of directions. Seen? All right. Any question? No question.
So please can you
Come again.
so please I was asking if you could go for it.
Okay, what I'm saying is that we earlier realized that the cosine rule is applied to any two vectors acting at an angle theta, whether acute or obtuse. And so when the angle is greater or less than 90 between two vector quantities, we are using the cosine rule to find the resultant. Okay. Then when the angle is also greater than 90, less than 180 obtuse, we are using the cosine rule to find the resultant. But I want you to understand that the cosine rule is a super rule because it can also be applied to all two forces. Its limitation is that it works for only two when you have two. Okay. But it can be applied to whether two vector quantities in one direction, in opposite directions, whether it's perpendicular, the relationship between them is perpendicular, acute angle, or so it's a super rule which applies to all directions so long as we have two vector quantities. So we are testing it. When they are moving oppositely to one another, this is going in this direction, this is going in the opposite direction, it implies that the angle between the forces 180. Okay. Here, yesterday we understood that the resultant would always be equal to subtracting the smaller force or vector from the bigger one. So if F2 is greater than F1, then the resultant will be F2 minus F1. One is the opposite, okay, or is the other way around. Then resultant will be F1 minus. Victoria, are you okay?
Yes, please.
But we could also see that this can be substituted into the cosine rule. All that you have to do is that substitute theta for the angle between them 180. And when you do that, you have cos 180 minus 180. This will be 0, for 0 is equal to 1. So R will be equal to what I've underlined here. And the underlying expression is equal to F1 minus F2 into bracket all squared. Now if I want R, I have to take the square root of both sides of the equation. And when you do that, the power 2 is eliminated. So R is equal to F1 minus F2, which is the same as what we saw earlier. And so all that I'm saying is that though we know when two forces are relating in this manner, the resultant can easily be determined using this. But we can also use the cosine rule to do the same thing. So that's basically what I'm saying. Are you okay? All right. Okay. Now let's look at. Oh, Ama, your line is breaking.
Mr. Adria.
It's better now.
Please, okay. Please, the vectors on the straight line, does it have any direction?
Oh, come again. The
vectors on the straight line, does it have any direction?
Oh, here we are looking at maybe a box. Ama is pushing to this direction. A box. Ama is pushing to this direction. The force applied is F1. So then your brother is also pushing in this direction. So Ama, you are pushing towards this direction. Your brother is also here, pushing to the opposite direction. Okay, and so it's like this. They are all along the horizontal. Am I okay?
Sir, please, I mean, like, it does it have theta?
Oh, when two forces are parallel to one another, theta is equal to 0.
Oh,
okay.
Sorry, yes.
Theta is equal to 0.
Okay.
Hey, no, here theta is equal to 180 because you are pushing opposite. The direction of the forces is opposite to one another. So theta is equal to 180, right?
Okay.
But
Yes.
when they are along the same direction, theta is 0.
Okay.
All right. Can we continue? Reposition and ask your question. Your line was breaking. Hello.
Mr.
Epia.
Mr. Edia, please, the ones whose angle make 180. Why is it that we didn't use theta to be 180, but we use 0?
No, this is what we did. You see, from the cosine, when you are subtracting, we have 180 minus theta. Is that okay? And so here, if we substitute, when the forces are acting oppositely, theta is 180. So we are just substituting 180 for theta, giving us minus 2f1 f2 cos 180 minus 180 because theta is 180. And 180 minus 180 is 0. Hence minus 2f1 f2 cos 0.
Yes, please.
All right. Okay. What a marathon. Okay. Let's look at expression of vectors into components. Expressing a single vector into components. A single vector has one component either along the x-axis or the y-axis. A vector. If a vector is along the x-axis or horizontal, or along the y-axis or vertical, it will always have a single component. This is what I'm saying. This is my x. Are you there? Adua Otubia Asante, are you there?
Yes, please.
Okay. So this is y-axis. This is x-axis. This is the negative y-axis. This is the negative x-axis. If a vector is along one plane, we can only have one component. Here, what I mean is that if we want to express the components of this vector in the xy plane or in a column vector form, as you were doing in your transformation, okay? If there is a point over here, you could only always trace it to get the x component, trace it, okay, to get the y component. So once it's in between y and x, you can always get two components for the vector. But if the point is here, you've done transformation before. If the point is over here, you would only have x component and 0 y component, isn't it?
Yes.
Isn't it? Good. That is the angle we are looking at our vectors, resolving vectors into components. So all that I'm trying to say is that if a vector is along the x-axis or y-axis, you can only have one component. The other component will be 0. So if I give you a force starting from here, there's a charge, so it ends here. Of this, it means that this force would, if I'm to express this force into components, this force would have a horizontal component, which is F1, but the vertical component will be 0. 0 because the force is along the x-axis. So this is equal to expressing it on the x along the XY plane. If a vector is here along Y, this is F2, and I'm asked to express this into components. This component will be equal to, what do you think will be its horizontal component? What do you think will be the horizontal component?
0.
Yes, 0. Good. So this will be 0, and this vertical component is equal to F2. And there is a vector here. Wait, mute yourself. Okay. Victoria, mute yourself. I'm praying. What are the components of this vector? Yes. What are the components of this vector?
F3, 0.
So F3 and 0. But that's not all. You have omitted something.
Negative.
Negative F3. Because this force is along the negative x-axis. You have to take care of that too. Yaba, are you okay?
Yes.
Epiadoma, are you there?
Yes, please.
Now, if I have a vector here, F4, and I want the component of this vector, Epiadoma, what will be the various components of this vector?
0, negative, and 4.
So 0, negative F4. 0 because the vector is only along the y-axis and has no relationship with the x. Negative because this vector falls within or along the negative y-axis. Class, are we okay?
Yes.
I'm asking. Oh, all right. Now, if the vector falls, if it falls within the quadrant, not along the plane, a vector is here. A force F1 makes an angle of theta degrees with the x-axis. You see, here, this force isn't along the x, okay? Nor can be seen along the y. And because of this, we'll have vertical and horizontal component. This time around, none of the components will be 0. We'll have complete value for both vertical and then horizontal component. So that's the essence of expression of vectors into components. Are we okay? That's the reason for which we are treating this subtopic under vectors. So it looks as if every vector can be expressed into two components, vertical and horizontal. Okay, but if it's directly on the x or y, then one component will be 0. So how do we express this into components? Now, in doing this, we resolve this into a right angle triangle. Okay, we need that this particular force, whose magnitude is F1, this vertical component will be this. The components will have to also obey the triangle law of vector. The horizontal will be this. So this is F vertical, and this is F horizontal. Instead of V and S, let's use Y. Because along Y as Fy, and this is Fx. Okay, the arrows must obey the triangle law of vectors, that this plus this must be equal to that, and they have to be perpendicular to each other, the components.
So these are the triangle law.
From this we could deduce that, oh, okay, then this direction Fx plus Fy is equal to F, and then the triangle law of vector addition. The triangle law of vector addition. Are we okay?
Yes.
So
Yes,
if
please.
if you have a triangle, and you are told that this is in this direction, and this side also, then it means that if this is in this direction, this is in this, then the third one will be in this direction. So if we can then deduce that then C is equal to A plus B by triangle law of vector addition, which we saw from yesterday. Please, okay, so the arrows or the component must also obey the triangle law of vector addition, and that's what we have established. Good. So if I want,
Mr. Edua,
hello,
please, but I think you said the triangle law of vector addition is used for scaled drawing, right?
so Amma, we cannot use that. We can the directions, okay, would confirm that, but we cannot use the law to find F because this is not a scaled drawing.
So, Mr. Dia, you can use it to determine direction.
Yes, the direction, okay, the direction would enable you to use the Pythagoras theorem. That if this is in this direction, this is in this direction, then the third one will be this. Okay, and because this is perpendicular to this, then I can use Pythagoras theorem to find F1 because this is not a scaled drawing. Okay.
Okay, thank you.
If it's a scale drawing, then you can, oh, okay, once it's scaled, then F is equal to Fx plus Fy. Then you are gone.
Okay, sir.
All right. So we want the horizontal component, we want the vertical component, formula or expression for them. Now, in right triangular measurement or trigonometry, I have a right angle triangle, and I'm giving the angle of inclination. I'm giving the hypotenuse, ABC. Once I have the angle, I have the hypotenuse, I can find this and that. Okay, to find the opposite, because I have the hypotenuse, the obvious trig ratio to use is sine of the angle, theta. Sine is equal to the opposite, this is the opposite side of the right angle triangle to this interior angle. So the opposite I'm looking for divided by the hypotenuse C. Therefore, the opposite is C sine theta. So it means that this component is C sine theta. Then, if I want the adjacent, which is this part is the part adjacent close to the angle. Close to the angle. So Because this is adjacent, the obvious trig ratio to use is cosine. So if I take cos of the angle theta, this must be equal to adjacent over hypotenuse C. So the adjacent is equal to C cos theta. So it means that if I'm looking for this part will be F1 sine theta. Then the adjacent will also be F1 cos theta. Once I have this and this, it's like I have the component of the force F1, xy, and this is equal to F1 cos theta, then F1 sine theta. By this, it means that I have resolved this force F1 into components. Resolution of forces into components. Class, is that okay?
Yes, please.
There is another way out. Here, I resolve this into components considering the angle it makes with the adjacent. I can also resolve the same force F1 when I consider the angle it makes with the vertical. Okay, earlier we considered this angle, the angle it makes, the force makes with X. We can also resolve this force F1 into components and considering the angle, the force makes with the Y-axis. Okay. Now, if theta is the angle this force makes with the X, what will be this angle?
90 minus theta.
Good, because if the whole quadrant sums up to 90 degrees. So if this is theta, this is equal to 90 minus theta. Class, is that okay?
Yes.
Okay. Now look at this. With regards to this angle, okay, the opposite side to this angle will be this line. Then with regards to 90 minus theta, this is the adjacent. The adjacent side. And we could deduce that the adjacent is perpendicular to each other. So to identify opposite, to identify adjacent, you have to consider the angle. If we are talking about this angle, then the side of the right angle triangle, which is opposite to this, is the side. The adjacent is this. The hypotenuse is always the longer side of the right angle triangle. So for the hypotenuse, it isn't difficult to identify. But the opposite and the adjacent is the issue. So the opposite side is always directly opposite to the angle in question. The adjacent side is that side of the right angle triangle, which is close to the angle in question. Is that okay? Now we have two angles here. So if you are looking at 90 minus theta, then the opposite side will be this. The opposite side to the angle 90 minus theta. Then the adjacent will be this. Are we okay? And this side might also obey the triangle law of vector addition. Once the hypotenuse is in this direction, then this must go here, and then this must also follow, so that this plus this is equal to that. And don't forget, these are equal vectors, this side and this side. So with with this angle, let's resolve this force F1 into components with the angle 90 minus theta. Meaning, if I want this side, let me indicate this as Fx. Fx, because this side is still within the x axis or the horizontal plane. So this is still Fx. Then this side is still Fy because it's still a side within the vertical or the y axis. Please, is that okay?
Yes,
Yes, please.
Good. So maybe I write this. This side is opposite to the angle 90 minus theta. So once it's opposite and I have the hypotenuse and the angle, the obvious trig ratio to use is
sine.
sine. So sine 90 minus theta would be equal to opposite, which is Fx, on hypotenuse, which is F1. So Fx now is equal to F1 sine of 90 minus theta. I want this. This is adjacent to the angle. So cosine, cos of 90 minus theta is equal to the adjacent, which is Fy on F1. Fy is equal to F1 cos 90 minus theta. So look at one funny thing. The same vector, okay, we can express it into components. If we look at it from the angle it makes with the x-axis, we had xy being equal to F1 cos theta and F1 sine theta. If we're looking at the angle it makes with the y-axis, the same thing is equal to Fx now is F1 sine 90 minus theta. F1 is Fy is cos 90 minus theta. The rule is that when I finish, I'll use numbers, which I think will bring the understanding better. The rule is that when you are resolving to the x-axis, to the angle with the x-axis or the horizontal, it is cos sine. The components become cos sine. If you are looking at the angle resolving the angle the vector makes with the y-axis, at the sine cos. So depending on where you are looking at, is it the angle with the x-axis? If you are looking at the angle the vector makes with the x-axis, the component become cos sine. If it's the angle the vector makes with the y-axis, it is sine cos. But whichever way you look at it, the value must be the same. Any question before I give you real figures to bring this point to clarity? Any question? Yes, Amma.
Sir, please, I don't understand what you just said. The rules.
Okay, let me give values. We have a vector or a force 100 Newton. Okay, making an angle of Maybe I'ma give me an angle.
120.
120. So here, let me use 60, and then we build up to obtuse angles. Okay.
Okay.
So maybe 60 with the x-axis. So this is the x-axis. This is the y-axis. And this is the 60. What is the 60? It means the angle, this force magnitude 100 Newton mixed with the y-axis is equal to what? Is equal to
100 Newton.
come again.
100
If the open, listen to the question. We are told the force of magnitude 100 Newton makes an angle of 60 degrees with the x-axis. So what angle will it make with the y-axis?
30 degrees.
Exactly.
60.
So this is 30, or your 90 minus 30. So we are resolving this force into components. Okay. I earlier said if the force had been along either x or y axis, we would have had only one component. The other component will be 0. But it's within this content. Is that okay? So clearly we will have to obtain two components for the force. All right. So I can resolve this force 100 Newton with the angle it makes with the x-axis, or the angle it makes with the y-axis. Let's begin with the angle it makes with the x-axis. So let's resolve this into a right angle triangle. And it means this side is the adjacent to the angle, right? And this
Yes,
side is the opposite to the angle 60. The adjacent, the opposite must always be perpendicular to each other. So therefore forming a right angle triangle. Okay. Now I want this component Fy. Want this component Fx. Y and X because they are along the y-axis. Y and X axis. Fx, if I want this side, which appropriate trig ratio do I use? Yes.
Cos.
If I want cos, y cosine, y cos, y cos.
Because we have the hypotenuse, but we are looking for the adjacent.
So because we have the angle itself and then the hypotenuse, don't forget it must be cos because okay, we are looking for the adjacent and we have the hypotenuse and the angle. So obviously cos is the reason. So cos of the angle 60 is equal to the adjacent Fx over the hypotenuse, which is 100. Let's make Fx the side. Fx is equal to
cos 60 times.
so 100 cos 60. Cos 60 is equal to 0.5 or half. And so 100 times half will give us 50 Newton. So the horizontal component of this force is 50 Newton. Then the vertical component. Clearly, we have to use, what ratio do we have to use?
Sine.
Sine.
Sine. So sine of 60 will be opposite, which is F subscript y divided by the hypotenuse, which is 100. If you make Fy the subject, we have 100 sine 60. Sine 60 is 0.8660. So multiply 100 by 0.866, and that will be 86.6.
6.6.
So it means this component is 86.6 Newton. What I'm saying is that I can also do the same thing by considering the angle, the same force mixed with the y-axis. And the angle it makes with the y-axis is 30. But if I'm using this angle, 30 degrees, then this side becomes the opposite to this angle. The side that directly faces the angle is the opposite. So this becomes, even though there is the opposite, but this side is still along the x-axis. The x-axis. So this side still becomes fx. Now, this is the adjacent to the angle. Even though the adjacent one is still within the y-axis, so this side becomes fy. Please, are we fine?
Yes, please.
No. If I'm using the angle to the y-axis, then if I want this side, which appropriate trig ratio do I use?
Cos.
Come again.
Sine.
I have two feedbacks here. I take it again. To this angle, this side is the opposite because it's the side which directly faces the angle. But this side will be indicated as fx because it's within the x plane, x-axis. Okay, this is the x-axis. So this side will still be fx, even though it is the opposite to the angle 30 degrees. This side is the adjacent, but it's along the y-axis, so it will be named fy. So if I want this, and they are perpendicular to each other, if I want this, what appropriate trig ratio do I use?
Tan.
Sine.
Sine.
I'm hearing no.
Sine.
Sine. You have to use sine because this is the opposite to this angle. This side itself is the opposite to the angle 30 degrees. And once is the opposite, and you have the hypotenuse and the angle, when you're looking for this, you have to use sine. So sine of what? Which angle?
30.
30. Is equal to the opposite, which is fx, over the hypotenuse, which is 100. Therefore, fx is equal to 100 times sine 30 degrees. And sine 30 is half. Therefore, this is equal to 50 Newton. You see, we are getting the same answer as when we had considered 60 degrees.
Yes.
Then, if I'm looking for this side, because I adjacent to this angle 30, I have to use cosine, right? So cos of 30 degrees because the adjacent, which is fy, on the hypotenuse 100 Newton. Therefore, fy is equal to 100 cos 30. Cos 30 degrees is 0.866. Okay, therefore 0.866 times 100, we have 86.6 Newton. And we are getting the same value. But the rule is that if you are resolving a vector into components and you are using the angle it makes with the x-axis, the component xy becomes cos theta sine theta. Okay, and if you're resolving with the angle it makes with the y-axis, the component becomes sine, the x component becomes sine, whereas the y component becomes cos. And look at what we've done. When we're looking for this, it's 100 fx. The x is so fx fy. This is equal to 100 cos 60, then 100 sine 60. When we're looking at the angle, the force makes with the y-axis, the components fx and then fy is equal to fx fy. Look at fx. Fx is 100 sine 30 and then 100 cos 30 degrees. So the rule, x is sine, for y is sine cos. That's the rule of the game. Are we okay?
Yes, please.
Now let's look at an obtuse angle, as Amma you mentioned. The angle between the x and then the y, the force and maybe the x-axis is 120. Please, can I clean the board? Do I clean the board?
Yes, please.
Okay. So, my y-axis, x-axis, the angle this makes with the x-axis is 120 clockwise. So, all that I'm told is that the angle that the vector makes with the y-axis, x-axis is 120. The force is 100. Okay, let me draw this well. So it makes an angle of 120 degrees with the x. Okay, I'm to resolve this into components. Or conventionally, angular measurement or in bearing, angular measurement is taken from the north, the positive y-axis. So let's sort of follow convention. From the y-axis or from the north, the angle, meaning this is the east or the x-axis. Okay, want to follow convention. The angle is 120. The magnitude of the force is 100 Newton. Our task is to resolve this into the various x and y components. The angle is 120. Maybe something like this, because we want to follow how the normal way of doing this. Now, by giving me an angle of 120 degrees, then it means that this is the angle, the 120 degrees is the angle this vector or this force takes with, is it a y-axis or x-axis?
X-axis.
This 120 degrees, is it the angle this force makes with the y-axis or x-axis?
Y-axis.
Is the y, because the norm, the positive y-axis. If this is the angle it makes with the y-axis, then straight away, the rule you learned is that when you are considering the angle to the y-axis, the component becomes yes. How does the component of the force become?
Sin theta and then cos theta.
So sine cos. So all that I do, I can do this straight away by, okay, then cos is 100, so it will be 100 sine of the angle it makes with the y-axis, 120, as vertical, as the horizontal, and 100 cos of the angle it makes with the y-axis, 120. So this is the x, y component of this force. Sine 120 is the same as sine 60, okay, which is 0.866. Okay, and so this will still be 86.6. Cos 120 is negative half. So this will be equal to minus 50 Newton. So these are the components of this. So when you're given this angle, you can consider the angle it makes, set a situation, you can consider the angle it makes with the y-axis straight away and then do it. Another way out. Please, are you listening?
Yes, please.
Okay. The other way out is that from the y-axis to the x-axis, what is this angle? What is this angle between the y-axis and then the positive x-axis?
90
Nine.
degrees.
So what will be this angle?
30 degrees.
So the angle this force makes with the x-axis is 30. I can also use the angle it makes with the x-axis. Okay, and when you are using the angle the force or the vector makes with the x-axis, the order of the component becomes what? Becomes what?
Cosine.
Cosine. Cosine. So the magnitude of the force 100 times cos of the angle 30. Then the magnitude of the force 100. Then the sine of the angle 30. But that's not all. There's you have to look at something else. You have to look at, you see, the axis within which the component falls. Look at the x component or the horizontal component. This is along the positive x, and then the vertical component, which is this, is along the what?
Negative one.
Negative, meaning that the x component will be positive, whereas the y component becomes what? Minus. Are you okay?
Yes.
So you have to also factor the quadrants within which the vector also falls. Now, cos 30, 0.866 times 100, giving you 86.6 Newton. Sine 30 is half, giving you negative 50 Newton. Look at the values. When we express it with the force, the angle it makes with the y-axis, and then the angle it makes with the x-axis. Are they different?
No.
So that's the beauty of the game. All right.
Yes, please.
I'm giving you examples to solve. 1 or 2 examples. Let me see how you can apply. I'm coming in. Okay, so the first question is this. Express the following forces into their respective components. Express the following, shorten following forces into their respective components. The force is P. The magnitude of this force is 10 Newton at an angle of 120. For bearings, angular measurement is taken from the north, so take note. Then we have another force R of magnitude 50 Newton at an angle of 210 degrees. For bearings, angular measurements are taken from the north, startward. So express them into their respective components. 5 minutes. Finish. Once you are not responding, it means you are finished. Agree, Adoma. Agree, Abuatuma.
Mr. Elia.
Finish.
Yes, please.
But you are not sure whether you finished or not.
I'm not sure if it's correct.
I Lizzie,
Yes, Miss Celia.
finish.
Yes, please.
Yaba,
Yes, Stadia.
finish.
Yes, please.
Adwa, okay. Then let's look at it. All right. So we have to express this. This is 120. So 120. Let's look at it from both angles. Okay. By considering the angle it makes with the x and then the y. 120. So for bearings, we take our angular measurement from the north or vectors for vector quantities. 120. And this is n. So once you are taking this from the north or the y, it is the component x, y becomes 10 sine 120, 10 cos 120. Sine 120 is sine 60, 0.86. This is 8.6 Newton. Cos 120 is negative half. So this is negative 9. Please, is that what you got?
Yes, please.
Yes, please.
How many of you got this? Lizzie? Okay. 4, 5, 6, 7, 8. Okay. All right. So let's look at it from x, the angle it makes with the x axis. This is 90, and so this is 30. So, hello,
Please,
Aresi,
you want to ask a question?
go ahead.
if you are like solving something like this, I'm supposed to like find it from both the x-axis and the y-axis, so you can just use one.
I am teaching you, so I'm giving you the two different ways.
Okay.
Mhm.
Thank you very
But
much.
but ideally one will do, but I want you to understand better. So this is 30. Once this is 30, then I can resolve it to the angle it makes with the x. 10. So 10 cos 30, 10 sine 30. Okay, this is x is positive. The y component is negative because this is negative y. So this is 8.6 and this is negative 5.0 Newton, and that's it. The second question. 115 acting at 210. So we are always taking our measurements from the y-axis. So this is 180. Let me change the marker. I'm coming. Oh shit. Okay. All right. So this is 180. Meaning I have to add 30 degrees from the y to give me, I have to add 30 to get 210. So the angle, look at something. The whole angle it makes with the positive y-axis 210 y. Another angle it makes with the y, this is the negative y-axis. This is 30. So another either 30 degrees or 210. Then if we look at the angle it makes with the x-axis. Okay. Once this is 30, this is 60. So to the x, it's 60. So we have three possibilities. And the magnitude is 15. So 15 sine 120. 15 cos 120. Or another angle it makes with the y is 30. 15 sine 30. 15 cos 30. But look at something. If we consider the angle it makes with that acute angle it makes with the y, okay, this side, you see, the x component is negative, the y component is also negative. So minus minus has to do. Hey, did I say 120? Oh, 210. And you also know correcting me. 210. 210. So both ways must give you the same answer. Check. Check. If you get the same answers, then you let me know.
Yes, please.
They all give you the same result.
Yes, please.
Okay. Let's look at the angle it makes with the x, 60. So 50 cos 60 and 15 sine 60. Over here, when I look at this, if x is negative, y is also negative. So minus, minus. Check. Let's see if it's the same as what you've had for the y.
Yes, it's the positive of it. It's the same thing.
So these are the two here. So you have three different ways. All right. So when the vector is within, if it's along the axis, the y, one component, the other component is 0. But whenever it's any angle in between, you have two components. Okay.
Yes, please.
All right. Another trial. Then you go back to the assignment I posted earlier. I'm coming. Okay, so the last try is that this time you are resolving S is equal to 12 Newton acting at 330 degrees. Please consider the two possibilities to see if you get the same answers. Okay, the angle it makes with X. If there's even 3, do so. Consider. Start with 12 Newton acting at 330. And not from the Y. Finish. Hello, finish.
Yes, please.
Yes, please.
Okay. So let me, I think, record your answers. Please, the rest of you, are you also doing it? Because I'm getting feedback from just a few of you. What are
Yes.
what are the answers?
-6 and 10.4.
-6 and what?
10 points.
10.1.
39.
Okay, so 10.4. Okay, so let's see. What the force is it 12? What's the magnitude of the force?
12 Newton.
So 310. So this is 270. Okay, 310. So 270 plus 60. Plus 60. So this is 60. Whereas this is 30. So the first approach is that once the vector makes a force of an angle of 330, 12 sine 330, 12 cos 330. Then the second possibility is the angle it makes with the y. When you use this, okay, whenever there is a negative, it will come by itself. Okay, 330 meaning that within 5 seconds, within this quadrant, only cosine will be positive. So this will be positive, this will be negative. But the angle, when you use the whole angle, it takes care of itself. Okay, so this will surely give you sine 330 is equal to, is the same as sine over 330. Okay, so point this for me, 12 sine 330.
0.5.
Okay, so this is -6. Then cos 330.
10.392.
Okay, so this is 10.3924. Okay. I can also use this angle to the y-axis. So 12 sine 30, 12 cos 30. But over here, x is negative. So this is negative and y is positive. Sine 30 is half. So -6 cos 30 is 0.866, and so it should give you 10.4. 4. The same answer. Now, when we use the angle to the x-axis, we have this, okay, and then this. That x is 12 cos 60. This is along the negative x-axis, so negative. Then 12 sine 60, which is along here, positive. Minus 6 is 0.86 times 12, which will be 10.4. So both ways would give you the same results. Okay. Okay, so I posted something earlier. I posted worksheets earlier on the platform. You see the forces 10 Newton. Let me post it once again. Yes, it has been reposted. We have F1, we have 10 Newton force. Between the 10 Newton force and the 17 Newton force, the angle is 90. Then between the 17 Newton force and F, the angle is 150. I want you to resolve each one, 10 Newton, 17 Newton, F, into vertical and horizontal components, to their various components. In our next meeting, we'll look at determining, I'll give you a value for F, then we look at the resultant force. Meaning we have 3 forces acting concurrently on a body or at a point. So for now, resolve 10 Newton, 17 Newton, and then F. F simply means that the magnitude of the force is F. Resolve them into the various components, X and Y components. Is that okay? So this is your assignment. Please, in our next meeting, we will look at the solution to all the assignments I gave you. Okay, from last time up to what I'm giving you today. So this is where I draw the curtains on our meeting today. Okay, we'll have another session next week. Bye-bye and take care of yourselves.
Bye.
Mm.